So now it's time to go into the more advanced stuff. You're probably in the series parallel, and now you're in over your heads trying to figure out how this works. You have also probably talked to some of your friends out in industry, and you're explaining, hey, I'm learning how to use the breadboard, and I'm using multi-sim and some other sophisticated tools to do these measurements, and they come back to you and they say, well, that's nice, but we don't use that out in industry. And here is the rebuttal that I have from being in industry, being in the automation and electronic repair world. I would strongly disagree, I guess is a better term, for what's going on here in the breadboard. Let's take a look at what's going on here. Much like in industry, anytime you have a circuit, you're going to have a power rail. In our breadboard situation here, we're going to have a power rail. This vertical rail with only two is going to be a power rail. So for example, let's say I want this circuit to have a negative rail coming out this way. So I'm going to make this negative. You can tell that this has been in the classroom because somebody's stripped the wires way too long. Let's make it negative. One way of making this whole row negative right here is to put a wire in and then jump this to my power supply. This now tells me that this entire rail is negative. If you work out in industry and you're doing AC wiring, this would be considered our neutral, and it would be a single bond point. Then I would have, say, a fuse, and I would have then a positive side going out there. So I would have the hot side. So for example, let's take this green wire, and I'm going to attach to, say, right here. And so this green wire now comes into here to my alligator. And what I like to do is I like to bend these out of the way. So that tells me anything along this very outermost column is going to be negative. Anything along this green column will all be positive. That is now a power rail. I can set my power supply to 5 volts, 10 volts, 12 volts, whatever, and I can start constructing series and parallel circuits. So let's do a series circuit, shall we? We want 2 resistors in series. Now, one of the very first things that we can do, and there's more than one way to do this, so this is why breadboarding is so important, because it allows us to screw stuff up at a very cheap rate. I can replace resistors for pennies as opposed to very expensive pieces of equipment. So I can go across right there. So I have a 2.2K, and now I have a 1K ohm resistor right here. So if I want a series circuit, I simply could do this. This could be a series circuit. Now, is it a complete circuit yet? No. And the reason it is not is I don't have a jumper. So what I could do is I could then add a jumper wire between the plus and the minus here. So the problem that we're going to face here, and when you do this, is there's multiple pathways. Now this wire will go down, but as I cut a video, notice what I have is negative, comes into this right here, jumps across, and then goes across and goes this way. This is one way of doing a series circuit. Another way to do series circuit could be possibly this way. I could have a wire jumped across, and then I can go across here. Our objective with using the breadboard is simply just to get us familiar with current flows. What we have here is the same series circuit. Now I need a wire that will jump from this side to here, or I could take that leg and stretch it out. Now the problem with doing this is a series circuit, and I need to measure current. What I will do on my multimeter probes, let's say I've got my meter set to current, and I want to read the total current of this series circuit. I need to physically lift this leg up, leave it up, attach my alligator from the milliamp side of that, place a jumper wire in, and I will use this as my jumper wire. And I will take this, and this will be the negative side, or the common side, as it were, for my meter. This is now the current from the negative, goes through, completes the circuit this way and back, and it comes through the meter, back, through that series circuit and back. So the point is, that is a series circuit. What about parallels? How can we do a parallel circuit? Well, there's obviously multitudes of ways of doing that. I can have 3 resistors, say, in parallel, and I can have jumper wires going between them. So let's say I have these 3 resistors and I want to make them in parallel. Well, I could simply add this wire right here. Now I've got a negative, but I don't have any jumps between these wires. This is where breadboarding prototype wires come in handy because now I can make these look real clean and neat. And that's the objective of what we're attempting to do when we look at our circuits, is how can I make these circuits look clean and easily viewable and then measurable. And then I can make this guy go to here. I'll add another green one right here. And so now I have a parallel circuit developing. I feel like being on a PBS TV show where they're doing painting by numbers. Happy little resistors are coming into play here. And now we have a parallel circuit developing. So this is one way of doing a parallel circuit. It's not the prettiest way, but it certainly works. The objective, like I said, is to have these resistors and the wires as clean as possible. And I like to use a little needle nose to make these connections look even better when I put them in. But I have now a parallel circuit going on. So here's my parallel circuit, and I'll put these two down. You get the point. So here's my complete circuit. Now I can tap off of any one of these and connect to the negative, and then connect here to the positive. So here is a complete circuit that is parallel in scope. So here it is. Remember, negative came from the jumper. Negative, negative, negative comes into this point. Because it's parallel, all three of these jumped across are in connection. This is no longer in connection. And then I've got a parallel, parallel, parallel. So the lines going across are all the same. So anything along that row will all make connection. Anything along that row will make connection. Anything that row will make connection. Now this is just a cheesy video. You're going to have to spend time doing this over and over and over again until you become proficient at it. You really need to be able to view electrons moving, kind of like viewing water flowing in a river, to know the difference between voltages and currents, between series and parallel. If you don't buy into that, you really will have a much more difficult time troubleshooting in the times that you get to those.